What's the relationship between amplitude and wavelength? A light travels forward along the axis of propagation. All the while, the individual points along the wave simply oscillate up and down, perpendicular to this axis. Amplitude is simply the maximum vertical displacement at which this occurs. Wavelength, on the other hand, is the distance associated with the wave repeating itself in this cycle of vertical displacement. Interestingly, there's actually no equation that relates these two variables together for electromagnetic radiation. However, while they don't affect each other, they do work together to manipulate the wave itself. More specifically, changing these variables changes the shape of the wave, graphically speaking. So here we have three waves, all with the same wavelength, as they have equal spacing between each consecutive node. What's different among these waves is simply that they have varying amplitudes. This is tall, this is medium, and this is short. As a result, with wavelength being held constant, increasing the amplitude makes our wave get steeper and steeper. In other words, skinnier and skinnier. This is measured most directly via the slope of the zero displacement nodes, i.e. what's the slope of the graph when we hit zero. Looking at this more closely, with constant wavelength, the bigger the amplitude, the larger the absolute value of the slope of these zero displacement points on that wave. In other words, this top wave has the biggest amplitude. This means that its zero displacement points, its nodes, have either really big positive or really big negative slopes. Whereas with smaller amplitudes, these zero displacement nodes, like these slopes, flatten out. Still, no matter what, the peaks and troughs always have a zero slope. Let's go vice versa. Now we have a constant amplitude, but our wavelength is different for each wave. This is big, this is medium, this is small. Accordingly, we can examine these zero displacement points as an indicator to the overall skinniness or steepness of the wave itself. Looking at this more closely, with a constant amplitude, the bigger the wavelength of the wave, the smaller the absolute value of these zero displacement point slopes. Notice how this effect is exactly the opposite compared to when it was amplitude being manipulated and wavelength being held constant. So to summarize the effect both amplitude and wavelength have on a wave, it's strictly on the shape of that wave. Steep waves are favored if we have a large amplitude and a small wavelength, whereas wide waves are favored with a small amplitude and a large wavelength.